Good morning everyone. So today we are going to start chapter 5, which talks about the change of basis and matrices of linear transformation. To begin or to see what we are going to discuss in this chapter, first recall the definition of the coordinates. So if S is a basis, then any vector V in vector space capital V can be expressed as a linear combination of the basis vectors, and here C1, C2, Cn are the coordinates of V relative to basis S. So for example, for R2, if you write 2, 3 as a linear combination of 1, 2, so it's 1 plus 1 times 1, 1, then you can see that the coordinates of 2, 3 with respect to the required basis are 1, 1, and they are denoted either as an element of Rn, or you can denote it as a column vector. Now this is the problem which we are looking for. If the vector space V has two bases, B and B dash, then, and if let's say we have the coordinates of V with respect to one basis, can we derive the coordinates of V with respect to the other basis from the given coordinates with respect to basis P? This is the question we need to look for. So let's assume that there are two bases B and B dash, and we have given VB dash, which means coordinates of vector V with respect to basis B dash. Please do remember the notations. And what need to be computed? I want to compute VB. Yes. Now these are the coordinates with respect to B dash. It means V can be written as K1 U1 dash plus K2 U2 dash. But U1 dash and U2 dash are vectors in V, implies U1 dash can be represented as a U1 plus B U2, and U2 dash can be represented as C U1 plus D U2, where U1 U2 is also a basis. And if I substitute the values here in V, then V becomes K1 U1 plus B U2 plus K2 CU1 plus DU2, or I can write V as K1A plus K2 CU1 plus K1B plus K2D U2, or you can say that I am looking for VB, which is K1A plus K2C and K1B plus K2D, which can also be represented as ACBD and K1 K2. Now the interesting thing to observe here is that this first column AB, so the first column AB, it is coming from here. And what are AB? They are the coordinates of U1 dash with respect to basis P, and the second column is the coordinates of U2 dash with respect to basis P, and then you have VB dash. So this is the relation where you can see the coordinates of V with respect to basis B can be derived if we know the coordinates of V with respect to B dash. This matrix is denoted as P, which is the transition matrix. Okay, so this is what we have discussed. I have already added it to this slide, and there we reach P is the transition matrix from B dash to B. Okay, so remember this notation. This is very important formula and you need to remember it. So VB can be written as P times VB dash, where P is defined as follows. And also remember the notation. This notation is PB dash to B. PB dash to B. So P b dash to b. And similarly we can talk of vb dash, just you need to change the other thing. So this is b dash to b, this is b to b dash vb. Okay, if you can remember these notations, then all the questions are simply based on these formulas. Only two formulas where one can be derived from the other. So let's move to the first question. It says that let b and b dash are the basis vectors where u1 u2 and u1 dash u2 dash are given. Find p b to b dash. So p b to b dash, which means that what you need to find, so you need to find u1 with respect to b dash and u2 with respect to b dash. So u1 means 1 0, you want to write as a linear combination of a times 3 4 plus b times 2 3. Yes, and these AB gives you the first column. Similarly, you want to write 0 1 as a linear combination of A times 3 4, or you can say C times 3 4 plus D times 2 3. So your P to B dash would be A B and C D. Yes, now calculations are quite easy. So if you solve them, you will get the following equation: 3a plus 2b is equal to 1 and 4a plus 3b is equal to 0. Solving them gives you a is equal to 3, b is equal to minus 4. Similarly, 3c plus 2d and 4c plus 3d is equal to 0 1. Solving them gives you c is equal to minus 2, d is equal to 3, and therefore your required pb to b dash, pb to b dash is 3 minus 4 and minus 2 3. Okay, next is to compute pb dash to b, which means that you have to write u1 dash b and u2 dash b. Now u1 dash b is very easy. 3 4 can easily be written as 3 times 1 0 plus 4 times 0 1, and therefore p b dash to b would come out to be 3 4 and 2 3. Yes, so as I told you, simply you have to remember the notations, rest is very easy. Next says that compute wb, where w is 3 comma minus 5. It means you have to write 3 minus 5 as a linear combination of basis vectors of 3 1 0 and minus 5 0 1. This means that your wb is 3 minus 5 only. Next it says that you need to find wb dash using the formula which we have discussed. Yes, so wb dash can be written as pb to b dash and wb. Now recall, we have already computed pb to b dash, so this is 3 minus 4 minus 2 3 and 3 multiplied by minus 5. If you solve it, it comes out to be 19 and minus 27. So this is my required wb dash. Also you can compute wb dash directly by writing w, which is 3 minus 5, as a linear combination of a times 3 4 plus b times 2 3, and that gives you homogeneous system of equation 3a plus 2b and 4a plus 2b is 3 and minus 5. And if you solve this non-homogeneous system of equation, this gives you AB is equal to 19 minus 27. Okay, so exercises are very simple. You just need to remember the notations. So I have added them in the slides also. And the next result says that if P is a transition matrix from B dash to B, then P inverse is the transition matrix from B to B dash, which makes sense. For example, if I write the formula VB, which is B dash to B and VB dash, then my VB dash is P inverse VB. So which means P inverse is P of B to B dash. Next, if you see, we have computed P B to B dash, but we are going to discuss a very simple method to compute P to B dash, and I will show you that why it is happening. Okay, so it says that if I have to compute P B to B dash, I must write the matrix in the form B dash B. Then I compute the RREF of the whole matrix, and the resulting matrix would be, on the left hand side you will have the identity, and on the right hand side you will have P B to B dash. Yes, now why it is happening? So recall that when we were computing P B to B dash in the previous example, so I wrote that P B to B dash. So I wrote 1 0 as a linear combination of A times 3 4 plus B times 2 3. Yes, this gives me system of equation 3A plus 2B is equal to 1, and the next one is 4A plus 3B is equal to 0. If I have to solve it, then my required AB, which is the first column of PB to B dash, so PB to B dash is AB, and this is the inverse of 3 2 4 3 inverse multiplied by 1 0. Agrees? Similarly, if I have to compute CD, it is the inverse of same matrix 3 2 4 3 inverse and multiplied by 0. The same I am doing here. Actually, when I write it as B dash and B, then I am multiplying the B dash inverse to both, and B dash inverse and B. So I am not multiplying B dash inverse to B. Actually, I am multiplying B dash inverse to the first column, which is 1 0, and then to the second column, and that gives you P B to B dash. The same which has been happened to the longer procedure, where you are indirectly computing the inverse 2 times, which need to be computed once only. So this becomes the identity, and this becomes P B to B dash. So again I am saying that you are multiplying B dash inverse with the first column and then with the second column. That gives you the first column here AB and the second column here CD. This is required P B to B dash. And similarly, if you have to compute P B dash to B, then you write B on the left hand side and B dash on the right hand side. So for example, if I have to compute P B to B dash, then I write B dash on the left hand side, which is minus 6 minus 6 0 minus 2 minus 6 4 minus 2 minus 3 7, and then minus 3 0 minus 3 minus 3 2 minus 1 and 1 6 minus 1. Then I compute its RREF. Then the left hand side becomes identity matrix and the right hand side gives me the required matrix. So this is the identity matrix, and you can see that the right hand side gives me the required matrix P B to B dash. If I have to find the WB, it means I have to write W as a linear combination of U1 U2 U3. That gives me the non-homogeneous system of equation. Again, if you solve it, then you will have the required answer. So this is WB, and WB dash can easily be computed using the formula which we have already discussed. So this gives me WB dash. So consider the basis P1, P2 and B dash Q1, Q2 as follows. Find PB dash to be. So for finding PB dash to be, I must write P and P dash. So now my B is P1, which is 1, 2 and P2, 3 minus 1. The only thing to remember here is the order. If I write P2 as minus x plus 3, then also I should write 3 minus 1. So you have to consider the order of the basis actually. So the basis is 1 comma x. So you can consider it as an ordered basis, and based on that you must pick the coordinates. And then the B dash is 2 minus 2 and 4, 3. Then you compute the RREF, and that gives you the required matrix, which is minus 4 by 7 and so on. So this is my PB dash to be, and similarly I can compute PB to B dash by following this procedure or by taking the inverse of this matrix. Both would work. So this is the last question, which says that let P be the transition matrix from B to B dash. So P is from B to B dash. So if you recall B to B dash, then you have V1 B dash, V2 B dash and V3 B dash. So first column is V1 B dash, V2 B dash, V3 B dash. And what is V1, V2, V3? It is basis B. So V1, V2, V3 is the basis B. Or instead, if the same notation is used, I can call them U1, U2, U3, and this is U1, U2, U3. So it says that let P be the transition matrix from B to B dash, where B dash is defined as follows. Then find B. So what I have given, I need to find P, which must be U1, U2, U3, and given is U1 B dash, which is 1, 0, 0. It means the coordinates of U1 with respect to B dash is given. So coordinates is given, basis vectors are given, I can compute U1. So U1 is 1 V1 plus 0 V2 plus 0 V3. Similarly, U2 is 0 V1 plus 2 V2 plus 1 V3, and similarly U3 is 0 V1, so 1 2 1 1 0 0 and 4 V2 plus 3 V3. Yes, so computation is very easy, but you need to understand the procedure. Once you understand the procedure, then it's quite easy to solve this one. And if you solve it, I think the answer comes out to be U1 is 1 1 1, then U2 is 2 3 0, and then U3 is 4 7 0. Okay, so this is the required basis B. So that's all from today's class. In the next class we will introduce the next section of this chapter. Thank you very much.